Okay, welcome back. Let's resume. We talked about what was a function, we talked about the graph, we talked about getting information out of graph. Okay, that was hard one. That was important. And then let's talk about average rate of change, 2.4 of our textbook, section 3 of this notebook. But this is very short section. I don't know if it is really worthy of spending our class time here, this extra video time here. Graphically speaking, it is just slope of secant line. Algebraically speaking, it's this formula. And it is because the average rate of change is given by the change of function value over the change of original variable. And original variable is x, so change of x is difference of x coordinate value. In terms of graph, it is 1. And the change of function value is change of y coordinate value. Graphically speaking, is rise. And that's about it. Change of y, so difference of y coordinate, over change of x, difference of x coordinates. So we have delta y over delta x, which is f of b minus f of a over b minus a. And there goes the average rate of change formula. Now let's do an example problem very quickly because this is not really worthy of a lot of our time. Let's see if we go over this kind of problem, what do you do? A value is given as -1, b value is given as 1, and then the function is given like this. All we have to do is plug everything into that average rate of change formula, and it's here, g of 1 minus g of -1 over 1 minus of -1. And g of 1 and g of -1, you can plug those values in and do the computation. You end up with -1. By the way, here's the graph. Slope of secant line, the red line segment is what you're looking at. Now, what if your function is given as a graph, not as an algebraic expression? Well, in that case, we'll have something like this. And please recognize this graph. You have seen this before. Now, let's find out h of 6 minus h of 1 over 6 minus 1. How do you do that? Let's just do finding out y coordinate values for given x coordinate values multiple times. Twice, actually, and that's about it. H of 6 minus h of 1 over 6 minus 1. H of 6, according to this graph, is 2. H of 1 is 4. So we have this computation. 2 minus 4 over 6 minus 1, ending up with -2/5. Graphically, the slope of secant line is, as you see here, slope of this red line segment. Okay, so much for section 2.4 of our textbook. Average rate of change, and then let's move on to transformations, and this one is going to be a little bit more worthy. Our textbook does, in my opinion, terrible job explaining this shifting, stretching, and flipping. The reason is because it is not coherent. It is not following a single principle. So I rewrote everything and I re-summarized everything based upon one single principle, that is an inverse operation. So you don't really have to memorize all kind of formulae. Just remember one principle, inverse operation. What do you mean by that? Here goes an example. Excuse me. Let's consider shifting in x direction by c. So blue is moved to the right in positive direction to the red. That's x direction, and apply inverse operation. Plus c in x direction, so we have minus c, and that's for x direction, so we have to do that to x. This x, which I highlight in blue, is becoming x minus c, which highlighted in red. And that's what it is. Inverse operation. Plus c becoming -c, minus c in appropriate direction, in x direction. Now, what if we want to go to the left-hand side, move to the left, shift to the left? That's -c value. So same formula, just apply negative value of c, and that's all. So you don't really have to memorize another formula for that. Now, what if you want to do the same thing to y direction? Shifting in y direction, or vertical shifting, going up or down, you don't really need separate formula. Just apply the same principle to y. plus c, apply inverse operation, so become minus c, and to which variable? In y direction, so you have to do it to y. And I highlighted and color-coded. Blue y is becoming red y minus c. And move this minus c to the other side, and we have this final expression, y equals to f of x plus c. That's the y graph here. That's the red graph here, excuse me. And what if you shift down? All you have to do is plug in negative value in place of this c, and that's it. Again, same principle. Now, let's consider stretching, expansion, stretching by factor of 2, like doubling or tripling and things like those. Here it is. Excuse me. The stretching is multiplication, so let's apply inverse operation. Remember, same principle, inverse operation. So what is inverse operation of multiplication? It's division. So this x, which I highlighted in blue, is becoming x minus c as highlighted in red. And blue graph is stretched by factor of c, and it's becoming red graph. What if I want to compress it? Instead of doubling it, compress it, make it half. All I have to do is plug in 1/2 in place of c. That's it. Plug in 1/3, then that becomes a compression. Plug in 3/4, that becomes a compression. You don't really need separate formula for compression. It's a stretching in appropriate direction. If you do the same thing to y, then you're going to get vertical stretching, stretching in y direction, as you can see over here. Oh, come on, kind of like that. And y divided by c is f of x. Flip the c to the other side, we have y is c times f of x, the final form. But in any case, it is coming from the same principle, inverse operation. Now, flipping is just putting negative signs, so you don't really have to consider inverse operation. Putting negative twice and you get positive x again, positive y again. So whether you go forward direction or backward direction, it won't make change. So just apply to appropriate coordinate here. If the flipping is done through horizontally in x direction, kind of like this, in other words, flipping with respect to y-axis, so consequently x coordinate is flipped to the other side. In that case, you just apply negative sign to x. So blue is becoming red. Can be a little bit confusing because the problems often say flipping with respect to the y-axis, but actually the change is done to x coordinate. So it's x direction. Toward y direction, do the same thing. Replace y by negative y, and then flip this negative sign to the other side, then we have y equals to negative f of x in the end. And that's flipping with respect to x-axis, or flipping in vertical y direction. So here's the grand summary. Everything is summarized in one single principle. Inverse operation in appropriate direction. So we were able to summarize this transformation, that's stretching, shifting, and flipping, in much more efficient way than the way they did in our textbook. So we can afford going a little bit deeper, like this example. Okay, and let's hide these for the time being. And here's the problem. Most of the problem in WebAssign are not this complicated. Excuse me. We begin with y equals f of x, the blue graph in the top left-hand side corner, and then shift it horizontally by -2. In x direction, we go -2, which means we go to the left-hand side. Then we end up with the second graph, red one. Now, second operation is vertical shifting, +1 in y direction, and we end up with a third graph, purple. And the third operation, third transformation, is flipping in x direction. So change the x coordinate to the other side. In other words, flipping with respect to the y-axis, and we end up with fourth graph, the brown one. Now, transformation number 4 is stretching in x direction, and we end up with fifth graph, the green one. And finally, stretching by factor of 7/3 vertically, we end up with the final graph, the sixth one, which is highlighted in thick, bold, black. Okay, let's go over to algebraic expression for each of these, and it kind of goes like this. Excuse me. We begin with y equals 1 over x, that's the original, and then we apply horizontal shifting by -2, so x is replaced by x minus of -2. So we end up with x plus 2, and that's going to give me the red graph. Now, let's apply vertical shifting. So inverse operation in y direction, so +1 will become actually -1 here. So y minus 1 is equal to, well, whatever we had in a previous graph, 1 over x plus 2. But then again, in order to take the next step, we have to flip this -1 to the other side. So we end up with this +1. That's the purple graph. Now, transformation number 3, flipping by y-axis. In other words, horizontal flipping, and so this purple graph is flipped horizontally to the brown graph, and that's obtained by replacing x by -x. Okay, so we have this brown graph, and then we have horizontal shifting, or horizontal stretching, excuse me. So we have the triple horizontally. So how do we do that? It's in x direction, and we are tripling it. So we do inverse operation. Divide by 3, so x over 3. So we have this green graph. Now the final step. What we need to do is we have to stretch it by factor of 7/3. So we have to apply the inverse operation. So we have to divide by this factor, and that factor is 7/3. I think I put a bit too many things here. So y divided by 7/3 is, well, that expression we had. So flip this 7/3 to the other side, and we end up with 3/7. And that should be the final answer. If you apply a little bit of simplification, come on, and we have this kind of answer. -7 over x minus 6 plus 7/3. So what can we see about this? This vertical asymptote is x equals to 6. That's when the denominator becomes 0. And horizontal asymptote will be y equals to 7/3. It's not pictured in the final graph, graph number 6, but it has horizontal asymptote, and that's 7/3. How do I know? If I plug in really, really large x, then this -7 divided by humongous denominator will be pretty close to 0, and consequently the y value will get closer and closer to 7/3. Okay, we still have a little bit of time left to talk about the next topic, so let's go. Addition, multiplication, and division. And I know for a fact you went through all these in intermediate algebra and then in college algebra. I know it because I taught those courses before. Addition or subtraction of function, just add of the function or subtract the function afterward. Multiplication, division, pretty much the same. So that's about it. Composition is a different story, and that's something we'll have to talk in far more detail later on, and that's something we are going to do at the very end of this chapter. And I'm going to tweak the order a little bit. I'm going to talk about inverse function first and then composition function later.